Good morning students, welcome to the physics class. In the last class we studied about Ohm's law, right? What is the equation for Ohm's law? V is equal to IR. What is V? V is potential difference and I is current and R is resistance. Today in this class we will briefly study about resistance. Resistance, as I said in the last class, what is resistance? Resistance is nothing but which controls the flow of current. In other words, the definition of resistance can be given as the property of the conductor to resist the flow of charge or obstruction for free flow of charge through the conductor is called as resistance. And resistance is denoted by capital letter R and SI unit of resistance is ohm and the symbol of ohm is written like this. And they may ask you a question, define 1 ohm. See, 1 ohm is nothing but the potential difference across the two ends of conductor is 1 volt and the current through it is 1 ampere. Then resistance is 1 ohm and this is written as 1 ohm is equal to what we have, 1 volt divided by 1 ampere. In other words, 1 ohm is not resistance. Volt is potential difference which is indicated as V and I is ampere, which is the SI unit of current. So this is the expression for resistance. R is equal to V by I. Now let us concentrate only on any two variables with resistance. That is, R is directly proportional to V when we neglect I, and R is inversely proportional to I when we neglect V. Now we know that R is inversely proportional to current. Now by looking at this equation, we can say that current and resistance are interrelated to each other, and these are the points how they are interrelated. First and most, we just need to remember these three things. See, we know that already what is resistance. Resistance is which controls the flow of current, right? And remember, if resistance is more, the current will become less, and the vice versa. If resistance is less, what happens? Current will become more. Now the same thing I explained in the point wise. See, the first one is if the resistance is doubled, the current is halved. So what it suggests, if resistance is increasing, the current will become half of it. And the second point is, if the resistance is tripled, then the current becomes 1/3. This is also suggest resistance is increasing and current is decreasing. And the third point is, if the resistance is half and 1/3, then current gets doubled and tripled. That means here the resistance is getting less and current is increasing. These are the points how current and resistance are interrelated. And here we need to recall what we learned in last class, that is Ohm's law. We draw the graph based on nichrome wire activity, right? What happened in that graph? We got an straight line which is passing through origin, and it indicates that current through the wire is increases as potential difference across the conductor also increases, right? And that tells the relation between V and I. Now let us understand factors on which resistance depends through an activity, same as we did in the last class for Ohm's law. Here this is our circuit diagram. Look at the circuit diagram. We have battery which is connected to ammeter, then it is connected to plug key, Here we need to have a related tabular column. We need to take results for 4 different cases. Now here also we are taking nichrome wire, and in the last class only I told what is nichrome wire. It is an alloy composition of nickel and chromium, right? Here also we are taking same wire, and see, this is our tabular column. We have 4 different cases and factors are different to each cases. Later, according to that factors, we need to record the current. So in the first case, what we'll do is, we will take nichrome wire and we will connect here, then plug the key. We will note down the current in ammeter. Let us take as I1. What is our first case? We took some length of nichrome wire and connected in between here, and we took the reading of current, let it be I1. And what is the second case is, the same wire we need to increase the length. The same nichrome wire we need to increase the length. What happens? Length will become 2L. Thickness is same here. Only we change the length. The thickness of the wire is same as first case. Now what happens if the nichrome wire is increased by length? It will be like this. Now we note down the reading. We will get I1 by 2. Now what you observed is, as length increased, current is halved. Okay. Now we'll go for third case. The third case, thicker wire, same length as first case. Here the length is same as the first case and the same material, that is nichrome wire, and here we are taking thicker the wire, that means only cross section area of the material is increased. So maybe our wire look like this. The cross section is increases. Now again take down the reading and we will get I2, which is greater than I1, means our reading is greater than first one. Now look at the results. The results are getting pretty interesting, right? Now let us go for the last case. The fourth case, it is different. Here we changed the material. Till 1 to 3rd case we are taking nichrome wire. Here we will change that wire as copper, and length and area of cross section are same as first case. Now what happens when we take this as a copper with same length and area of cross section? We saw that the reading is greater than the first one. Now observe the result. What we saw, first one we got some reading, and when we increase the length we got that current as half of the first one, and when we increase the size of the wire with the same length we got the result greater than the first case. And in the fourth case we changed the material from nichrome to copper, and we saw our current is much greater than the first one. Based on this activity, we can say resistance depends on these following factors. The first one is length of the wire, and the second one is thickness or cross section of the wire, that is A, and the third one is material of the wire. Now here I'll include one more point. Remember, material may be conductor, alloy or insulators. Always remember, this is the symbol for resistivity called as rho. I'll explain you later what is that. Now just understand, resistivity of conductor is lesser than alloy, and that is lesser than insulator. Based on this, we have one column in textbook, and I have included that column in your PDF notes. We'll get problems related that, or we need to justify using the table some of the answer. Just remember, conductor is lesser than alloy, and it is lesser than insulator in resistivity. Now just observe here, what we have here, copper. We got highest current value, right? So copper is what? Conductor. Alloy means what? Mixture of material. That is nichrome is alloy and here copper is conductor. That means if the copper, the resistivity is less, what happens? As I said earlier, if the resistivity or resistance is less, we will get current more, right? So copper has less resistivity. That's why we got more value in current. Now the third point is resistance depends upon material of the wire. The last point is temperature also matters here. Temperature of wire. When we are conducting these experiments, some of the terms should be same or constant while conducting. Therefore, temperature also included in one among the factors. They may ask you for 2 marks to list out the factors on which resistance depends. So, try to understand and remember these 4 points. From this activity, we can also figure out some important points which are useful to understand the concept in depth. They are: current flow easily if temperature is less, and as length of the material increases, current becomes off of it. See, when we increase the length, what happens? Current is halved. So as the length of the material increases, current becomes off of it. That means more the length, more will be the resistance. It can be written as R is directly proportional to length. And the next point is, if thickness of the material increases, the current flowing through it also increases. Look here, when we increases the size of the material, what happens? We got more current than the first case. So it suggests that when thickness of material increases and the current flow in it also increases. And the one more point is, current is inversely proportional to area of cross section, which we can observe through the second, third case. From first and second cases, we can write I is inversely proportional to length, and from Ohm's law we know that I is inversely proportional to R. By looking these two equations, we can write R is directly proportional to length. Length of wire and area of cross section of a wire is interrelated to each other, which can be shown as R is directly proportional to length and R is inversely proportional to area, which are called as equation 1 and equation 2. By combining equation 1 and equation 2, we will get R is inversely proportional to L by A. To remove the proportionality, we will introduce proportionality constant called as electrical resistivity, which is the symbol rho. Electrical resistivity, which was written as this symbol called as rho. We will introduce that term, then equation will become L by A, and this is the important equation of resistance. Here R is resistance and this rho is called as resistivity, and L is length, A is area of cross section. Now let us see, SI unit of resistivity is ohm meter. Let us see how we got ohm meter. What is the formula of resistance? R is equal to rho into L by A. And what is the unit of R? That is ohm. We will keep rho as it is. What is the SI unit for length? M, and A, that is area of cross section, is meter square. We will cancel this one. When we cross multiply this, we will get ohm meter, which is equal to resistivity, and this is the SI unit of resistivity. Let us see few difference between resistance and resistivity. Resistance is a property of a conductor which opposes the flow of current, whereas resistivity is a property of a conductor with unit length and unit area of cross section. We need to define resistivity using its formula, that is R is equal to rho into L by R, and SI unit of resistance is ohm, here ohm meter, and here it is denoted by R, it is denoted as rho, and it depends on length and area of cross section. Here resistivity does not depend on any factors like length and area of cross section. Let us solve example problems related resistivity. The first one is, resistance of a metal wire of length 1 meter is 26 ohm at 20 degrees Celsius. If the diameter of the wire is 0.3 millimeter, what will be the resistivity of the metal at that temperature? And using table 12.2, predict the material of the wire. Given length is 1 meter, resistance is 26 ohm, diameter is 0.3 millimeter. Now we need to convert this millimeter into meter. Convert according to your own convenient way. That will be easy for your calculation. I have shown all the three different ways. 0.3 into 10 to the power minus 3 meter, or else we can write like this, 0.0003 meter, or else we can shift this point to here and we can write it as 3 into 10 to the power 4 meter. And we need to find out resistivity. This is the symbol for resistivity called as rho, right? And after finding the resistivity, we need to predict the material by looking at the column which is given in the textbook and I have given in the PDF also. What is the formula for resistivity? R is equal to rho into L by A. We need to find out resistivity, right? So modify this equation, take rho outside and we will get R into A divided by L. Now we have all the numbers except A. What is A? It is the area of cross section given by the formula pi into d by 2 to the power square. Now substitute all the numbers in this equation. We will get 26 into, what is the value of pi? 3.14 or 22 by 7. Then d is, I have taken this value 0.0003 divided by 2 to the power 2, and length is what? 1. Calculate and we will get this answer. The power may be vary based on your calculation. Later on, by looking at the table, this is our resistivity. We need to predict which material is this, right? After, by looking at the table, adjust the power, so it will be same as in the table. So this can be altered by shifting the decimal. So if we shift here, here and here, we will get 10 to the power minus 6. Hence resistivity is 1.83 into 10 to the power minus 6 ohm, and the material is manganese. Our next question is, a wire of given material having length L and area of cross section A has a resistance of 4 ohm. What would be the resistance of another wire of the same material having length 1 by 2 and area of cross section is 2 ampere? Read out the question again. We have two wires. There are two wires. For the first wire, they are given R1 as 4 ohm. In that, they are clearly mentioned that 4 ohm is the answer of both length and area of cross section. So remember this one. In the second wire, we need to find out resistivity. They are not given. They are given only two things, that is L is 1 by 2 and area is 2 ampere. Now we know the equation, R1 is equal to rho into L by A, right? For the same equation, we will take for R2 and substitute the values. Rho, they are given rho Now L is what? 1 by 2, substitute here, and A is 2 by A, and we substituted here. Now we need to concentrate on the how we are modifying the steps. So here 1 by 2, when this 2A in the denominator goes to numerator, it will become 1 divided by 2A, right? Then what happened? Take out this 1 by 2 into 2, that is 1 by 4, and separate the term rho and remaining 1 by A. Now see this carefully, rho into 1 by A. What it indicates? This is equal to R1, right? See, go back here for the first wire. R1 is what? Rho into L by A is equal to 4 ohm. Now we can write this term as 4, right? So substitute this as R1 and hence write the number. Then 1 by 4 and 4 will get calculate. They will cancel and the answer is 1 ohm. Therefore, the resistivity for the second wire is 1 ohm. In today's class, we learned about resistance and factors on which resistance depends through an activity, and we know about resistivity and resistance, and we solve few numerical problems. You should be up to date with your notes and homework. Today solve the homework related resistance, and I want you people to solve few more questions. Now you all have textbooks, right? Till the resistance, in between the chapters we have questions. Try to solve them. In the next class I will discuss answer for them.